Good morning, everybody. My name is Alex Mackey, and this is eXential XSS, or cross-site scripting. I'm a staff engineer at an organisation called Willow. We specialise in the development and implementation of digital twins. I've recently moved into an AppSec role. I've had various roles in consulting, product, in all sorts of different pieces, but now I've got a bit of a focus on security. So what are we going to be talking about today? Well, we're going to talk about a number of different things. I want to start off, we're going to look at the history of XSS, where XSS actually came from. XSS is divided into a number of different types of approaches, and they've all got their distinct characteristics, things to watch out for, and things to be aware of, and I want to show you these. I think sometimes there's a bit of a perception that XSS is it's a bit of an annoying issue, and an attacker might be able to use it to maybe throw up an alert box or maybe annoy the user. I don't think that's true, and I think XSS can be a very serious issue indeed. And I'm going to show you several examples of this during the presentation. And we're going to go right up to actually running some code via XSS on the machine and getting an interactive terminal or remote code execution. And at that point, I guess it's kind of game over once you can run code on a web server itself. XSS is actually quite hard to identify sometimes, and I want to show you how tricky it can be and some of the tricks that attackers will use to circumvent detection and filters. And then if we get time, I might just touch on a couple of examples with React and some things to be aware of there. All the slides and code, everything I'm going to show you, it's all available. Don't feel you need to take photos or anything of it. It's all up there for you to use. Head over to my GitHub and you'll find this stuff there shortly after the presentation. So before I start this, as it's a security talk, and I'm going to be showing you some things which would be illegal to do if you don't have permission to, I kind of need to put this warning out here. We are all adults, but if you do some of these things on sites that you don't have permission to do so, you could get in a lot of trouble. You could potentially even go to jail. Please don't do that. If you do want to play with some of these things, I'm going to show you some examples, and I've got an application you can download to play with it. But don't go away, try these on some big sites or your employers. If you do this stuff, you need permission from someone to do it, and it also needs to be permission from someone who is authorized to give you that permission. If you turn to your mate sitting next to you and go, "What do you reckon?" they may not be the person that can say, "Yep, you can go and attack this $1 million company's website and cause all sorts of damage." So please do be careful with this. There's a lot of options if you do want to learn about this type of thing. For me, I think you can't really learn and understand some of these concepts without actually understanding how someone will attack an application. So we kind of want to learn that defense through also understanding the offensive aspects of this. Two really good sites and applications for this are Try Hack Me and Hack the Box. So if you try Hack Me, if you've never touched this stuff before, they've got a heap of labs, tutorials, and workshops you can go through. It's quite good fun. It's only about $10 a month, very good value, and you'll learn a lot with this site. Once you've got some of the basics down, Hack the Box is also a really good option. Again, about $10 a month, but here you'll be expected to have a certain level of knowledge. You'll have various boxes and puzzles to work out. I had a lot of fun with these, especially over the lockdown period when there wasn't a lot else to do, and they are a great way to learn. This morning, I'm going to be showing you an application which I developed. This is a small Node MySQL application. I wanted something small which had a heap of vulnerabilities and issues that I could practice with, that I could script with, and I could play and understand some of these things. This is available to download. Please have a play with it. It's got heaps of different issues that you can play with. SQL injection, something called local file includes. There's all sorts of different things here if you want to go and learn about this type of stuff. So this talk came about because I was interviewing front-end development candidates, and we'd ask various questions during the interviews. And one of the questions I would ask is, tell me about XSS or cross-site scripting. Now, I wasn't expecting a detailed level of knowledge, but it came as a real surprise to me that when I went and asked people what XSS was, the vast majority of them actually just didn't know. Some people got confused with various other types of issues, but the majority of people didn't know. This was a bit of a surprise to me, and also a bit of a concern. How big an issue is XSS? Well, it turns out it's rather a big issue. It's estimated that about 20% of all security bulletins last 3 years were due to XSS. We have estimates of over XSS issues existing in over 60% of applications. Edgecast, who provide various web app firewalls and services and monitor traffic, they found an enormous amount of traffic appeared to contain XSS attacks. And interestingly, it wasn't even targeted at some of the big sites. It was just everyone. So there's various folks out there, God knows what they have in mind for this, but they're just literally hitting everything they can with some of these issues. So even if you're a fairly small site or organization, if you don't protect against some of these things, you may be hit by some of these attacks. XSS is consistently high in, I suspect we're all familiar with OWASP's top 10. If you're not, please take a look. It covers the main security issues in a prioritized order. A lot of discussion and I guess statistics go into determining what's the top issues at the moment, and then it gets reviewed every few years. XSS is consistently near the top of this. They did a bit of a rearrangement of categories, and it's currently in the injection category, along with things like SQL injection, but still very much a big issue. For those of you familiar with bug bounty programs, it's just so common that some of these will actually exclude XSS from it entirely. It seems a bit of an issue, but I think we can conclude from some of this that even though this has been around a very long time, it's still very much a big issue here. So we find the term XSS used, first of all, in 2000, and Microsoft published a report with an organization called CERT. And what they were getting was reports of people referencing malicious scripts on another web server. And that's where we kind of get that cross-site scripting, because that was a script that was being run from another web server there. I'm going to show you some examples today. It is much more complicated than that, and there's a lot of different ways of applying this. But that's where we first see this term. So that's 22 years ago these things started to appear, and it's still one of the main issues today. I think part of the reason people don't understand some of this is that XSS isn't really a very good name, or cross-site scripting. For me, and I don't have a nice snappy thing, it's running code in other people's browsers from sites you don't own. That kind of encapsulates what we're going to do with this and what I'm going to show you this morning. But first of all, let's take a web page, and let's say that you could run JavaScript code. It doesn't necessarily need to be JavaScript. It could be HTML, even CSS. There's various attacks via CSS, believe it or not. What mischief could you get up to if you have the ability to do this on a web page? Well, quite a lot of things. And this only expands because I think now we can consider that the web browser is almost a mini operating system in itself. There's a heap of different sort of APIs that we can use here. We've got location stuff, we've got microphone, we've got access to the web camera, we've got Bluetooth, we've got a vibration API, we've got battery APIs. There's an enormous amount of power and functionality here. Now, of course, in order to use some of these APIs, the browser will pop up a permission dialog. It'll say, do you grant location permissions? And the user will have to grant that. But there's a lot of different options here. What can we do with some of this? Well, quite a lot. We could manipulate or deface a web page. That could be anything from someone just posting something annoying to actually potentially manipulating markets and so on. If someone posts some fake news story, they overwrite some content and change some stuff there, that could have a very real effect on things if you're able to manipulate the content of a popular site. We could use it to read sensitive information on a page. If someone's logged into a banking application, we could maybe read out their balances and so on. We could read cookies, local storage information, that type of thing. We could potentially reset the user's password to a known value. We could make requests to the services as that user. We could redirect the user to a malicious site, michaelbuble.com, something terrible like that they could be sent to. Or maybe they're sent to another site to go and download some malware. That could be pretty serious, and that's one line of JavaScript, window.location equals whatever it is. We could potentially use modern APIs like the camera. We could even take a picture of them. Now, the user sometimes would have already given permission to the site for some of these type of things already. And then there's also an issue called server-side request forgery, which I'll talk about a little bit later. Now, some of these things do depend on other protections in place and certain configuration as well, which I'm going to talk about. One of the sort of fairly early examples of XSS I like is the Sami Worm. Now, Sami Kumar, discovered an XSS issue in the site MySpace. And what he did with this is he used it to post the text, but most of all, Sami is my hero, and send himself a friend request. So it wasn't really particularly malicious, but you can imagine what it must have felt like when he discovered this issue, thought he'd have some fun with it, goes to bed, 20 hours later, discovers he's got over 1 million different friends requests. So I suspect at that point he probably had a bit of a sick feeling in his stomach, because that's not the sort of thing that's just going to go away on its own. I believe he did end up getting fined from this, but I think he's doing okay after that. Let's get into some demos, and the first thing I want to show you is a demo of the different types of XSS. Now, I'm going to use my test application. As I said, it's a Node application. I use a templating framework called EJS. It's very easy to understand. I've tried to make it as simple as possible with as few dependencies. And what we have here is an example of an online shop, cat bicycles. So a shop specializing in bicycles for your cat. And if anyone wants to invest in this afterwards, please go and see a psychologist. We will get into this now. So we've got our bikes here, and we're going to go into the detail of our bikes. Now, I guess this is kind of the canonical example of XSS here. We have the ability to review a product here. And we've got a text box here where we can go and add some details. So one of the first things that you could start doing is potentially using formatting tags. So the reason we might do that, or an attacker might do that, is because they're less noticeable than some of the other things. So if we put, say, a bold tag, or even a marquee or something, and you find that that renders, that we know that that output hasn't been encoded properly. What do I mean by that? Well, let's put in kind of our hello world XSS. So I'm going to open a script block, and we'll type in hello world, and we'll close that script block off, and we'll go and submit that. And it's probably no surprise, or hopefully of no surprise, that once that comment's been added, we now have an annoying JavaScript alert box fired off there. So we've confirmed here we have the ability to run code on this page here. Now, the reason that run is because it was not encoded properly when we output the comments there. So if I was to go into the view page source, we'll search for hello, and I don't know if that's a bit small there. We'll see if we can zoom in a bit. We can. We can see we've got our script block there rendered unencoded, as if we'd written that ourselves. Now, I've deliberately put this particular issue in there. So I'm going to go into my templating framework here. I'm using a templating framework called EJS here. I wanted something pretty simple. And in EJS, when you go and output some content, you have two ways of doing it, essentially. This %- tells EJS, don't encode anything, put it as is on the web page. So we could fix that one up if we go and change that to an equal sign. We'll go and refresh the page there. And then we didn't get that block there, and then we got this code output as we'd expect there. And then, of course, if we go and have a look in the page source, we'll go search for hello again, And instead of that script tags, we've got this block here, and it's HTML encoded it as it should have done. So that's good. That would protect us against XSS there by ensuring we properly encode the output. Now, I'm going to deliberately create that issue again because it's going to be easier to show you some of these other things. And it would be a short presentation if we went and sorted everything out right from the start. So let's put that issue back in again. Now, what I've shown you there is an example of Stored Xss, and it's Stored Xss because we've taken a value and it's been stored in a database somewhere. In this instance, there's a MySQL database operating behind the scenes that it's gone and put this in. Stored Xss, I think, is more serious than some of the other types I'm going to show you. And the reason for that is because once you get it in a database, anyone coming to this page is going to get served up this content. So through no bad actions of their own, they're browsing around and they want to go and buy a bike for their cat, and then they're hit with our annoying JavaScript alert box. Let's look at the next type. The next type we have is reflected XSS. Now I'm just going to use this button here I've created for demo purposes just to go and remove everything so we don't have any other issues kicking around. Now the other type of issue we might have is called reflected XSS. And what happens here is instead of actually getting the data stored in the database, it's taken from something like a query string parameter or header and then output on the page. So I don't know if you can make it out there, but in the query string it says greeting equals Alex, and then we've got hello Alex at the top of the page. And there's some code which is just looking for the query string parameter and putting it on the page there. And then, as you might guess, we could then go and change this, and we can go and give it a script block instead, and then have that executed. Now, it is a different type of attack here, because in order for this to occur, it would require the user to go to this particular URL. So this could be the sort of thing that you might get from a malicious link, an email, that type of thing. So there's a bit more to it in order for this attack to actually occur. So I think it's less serious, although it can still be a pretty serious issue than Stored Xss. Now, there's also a third type, and the third type is called DOM-based XSS. So in DOM-based XSS, we make use of, we need to find a function which is manipulating the page DOM, or document object model, and inject something into that. Now, in this example, I've got the query string parameter special offer equals 10% discount, and we can see that that's gone and output some horrendous big blue text there telling us about the special offer. If we go and have a look at what's actually going in on the code there, then we'll find some dodgy JavaScript that I wrote where we go and get the query string parameter, and then we've output it on the page here. So it's a kind of a different mechanism that this is going to get in there, and of course we could then go and exploit that. I'm going to use an iframe here with the source set to JavaScript load in order to exploit this, and there we have our DOM-based XSS there. So that's the three main types of XSS. Before we move on, just as an example, we could also use this. We're going to go and manipulate the page, and as it's a cat-based website, we'll go and leave a nice message for those browsing bikes for their cats. We'll go and manipulate the page and put up a GIF there. Cool. Let's delete that and move on. So in order for XSS to occur, there needs to be a few different things in place here. Now, the first thing you need is controllable input. And this is kind of where you need to start with your applications and understanding where are all the places that the user can control the input. So in our examples, the user had the ability to add a comment, they had the query string, and they could change this to whatever they want. If the user does not have an ability to do this, then there's no way for them to get that sort of malicious code in there. Now, the other thing that needs to be in place is there needs to be either a complete lack of or flawed validation on that input coming in. Because if we'd had input validation on that comments box, that may have prevented those XSS issues we showed there. The better sites will also sanitize some of the input coming in, so it might look for malicious code, script tags, and so on. We need the input rendered unencoded, so it needs to be able to execute. And it also needs some kind of browser to run it. Now, when I say some kind of browser, because it doesn't have to just be a web browser. We have all sorts of devices. Sometimes some of the PDF rendering utilities, they actually behind the scenes use a web browser in order to render HTML content. And potentially some of these things could work and execute some of these code. Now, the other thing that needs to be true is we need to make sure that additional protections are not in place. I'm going to talk about some of these in a minute. So, of course, first of all, please make sure you're encoding all user controllable output. Be very, very careful if you start allowing things like formatting tags and so on. As I'll show you, it is very, very hard to sanitize and ensure this input is safe. Well, this brings us to the question of, okay, if we go and do this encoding, does this mean that we're safe from XSS? Like, that looks a pretty easy fix in our example. Well, maybe not. So there was an issue in Chromium in 2021, which around parsing of the page DOM, and that had a circumvention method. So even the browser manufacturers make some mistakes in some of these things. So even if you're doing everything properly, there is still that possibility that there could be an issue in it. Templating engines regularly have issues. There's quite a well-known one in Angular. We see bugs in tools such as Adobe PDF Reader and so on that will utilize read web content. That one's a bit older, but just be aware that there's a lot of different other things consuming these things. The next one I want to talk about, though, is if we can get a malicious payload into a database, then it could potentially be rendered, it could end up being rendered in a downstream system. What do I mean by that? Well, let's take our cat bicycles example. If we can get some malicious content into the database behind that, it's quite common in a non-trivial system for, say, in an enterprise, for data to be taken from one database to another and potentially consumed by older systems, and maybe systems that aren't as well tested or don't have the same protections in place. That could be anything from emails going out sent to a user. It could be a mobile device. Maybe it gets passed on to another database, which then consumes it, renders some PDFs, emails out stuff. So be careful with this, because it's pretty common for this type of data to be passed around. So even though the system you're working with might be safe, you might not be aware of some of the other things consuming this. Here's an example of this happening. Tesla. So if you're lucky enough to own a Tesla, apparently it has a function where you can name your vehicle. So if I was to own a Tesla, I could put Alex's Tesla. This actually had an XSS issue in it. And there was a guy called Sam Curry, and what he did was, in his name the vehicle, is he tried a XSS payload. Now, it didn't do anything at the time, and this is the interesting point. He probably had a jumble of code on the screen when he looked at his Tesla's name, but he then took it in for a service to Tesla. And Sam was using a system called Xss Hunter. Now, this is a free application you can sign up for in beta. I believe, off the top of my head, it was designed by the head of Snapchat's Red Team. And what this does is this gives you a unique endpoint that you can call, and a script for you to attempt XSS attacks. And if an XSS attack is possible, it hits this unique endpoint for you. And what do you get? Well, you get a nice interface like this, where it dumps a screenshot of what the user is currently looking at, all the cookies, any information that it can get out of any APIs on the page. And to Sam's surprise, he'd set this up for his Tesla, and when his car went in for a service, this was triggered, and he's probably looking at a picture of Tesla's internal systems there. Probably not what Tesla wanted. There could be all sorts of things on that page. with a bit more work, we've now got some malicious code running in a secure, presumably secure network. All sorts of horrible things could go on there. So do be very careful with this, because systems are linked together. They don't operate in isolation. And it's quite easy to miss this with things like an admin application or something for controlling reference data, maybe performing one-off functions and so on. What should you do about it? Well, consider sanitizing user input. I say consider because it would obviously be a heap of work to take every single value that the user will provide. It will add some overhead, but maybe it's worth doing. If you've got a very high profile site with a lot of traffic, it could well be worth doing. And don't write this stuff yourself for reasons I'm going to show you about towards the end of the presentation. So far, we've discussed stored and persistent XSS, that's the one that was in the database. Reflected, that's where it came from the query string, but was actually then output on the page itself. We looked at DOM-based, where we used the JavaScript function in order to go and exploit that. And then we looked at blind XSS. That's that Tesla example where you put that payload in. You don't really know if it's going to run, but then it was kicked off. A couple of other examples, self-XSS. Why would you want to XSS yourself? Yep, bit of a weird thing to do. I don't know if anyone saw some time ago, I saw it on Facebook, there was this thing going around where it said, hey, if you run this block of code, it will tell you who has looked at your profile. And human beings, being the curious folks we are, who's been checking me out? And you can imagine a lot of people probably run this code in the browser console without really knowing what they were doing. That code would have run in the context of that user. Maybe it changed their password. Maybe it installed some horrendous app. I don't know. That would require a bit of social engineering, tricking people into it, but it is a real issue to be aware of. Mutated XSS. It turns out as developers, we're actually pretty bad at writing valid HTML and JavaScript. And what browsers will do when you do things like forget to close a tag or you nest tags that shouldn't ever be nested, is they'll do some of the work for you and they'll go and manipulate some of these tags and try and have a good guess at what your actual intentions were when you were putting this on a page. Sometimes this is possible to exploit in order to run XSS. Even the big guys had a problem with this. The Google search bar, I think a number of years back, had an issue with this, where you could make use of malformed tags and it would correct it into something evil. Okay, well, we've added a pug GIF, we've popped up some annoying alert boxes. What else could we do? Well, I think the next thing we probably want to talk about is cookies. Now, cookies are still used pretty extensively in order to manage sessions of the user. What I'm going to do here, and I'm running from Ubuntu here, I'm going to run up an application called Netcat. Netcat's really awesome. It's this little tool that can do all sorts of listening on ports, sending to ports, you can send files. I think they describe it as the network Swiss Army knife. It's a pretty cool tool. And what I'm going to do is, because I lose the ability to type when I'm presenting, I'm going to go and copy some code here. And this is my XSS attack here. And I will show you what it is shortly. I'm going to paste it in the box there. And we've got an image there. And we can see on the onLoad attribute there, that we're going to set the source, in this example, the loopback address or my machine, port 9000, and we're going to pass across the user's cookie. But before we do that, I'm just going to log into the application, and we'll go back there, and we'll paste that in. I'll go, and we're on the wrong port there. I'll go to 9000. We'll hit that up, and we've now got a listener on that port there. We'll go and save that image there, and we'll go back. And we can see we had a connection there. So when that image loaded, it set the source to my machine there and also sent the cookie there. So we can see we've got that cookie string there. So in a real world example, that might be an attacker's web server. But what can we do with that? Well, as far as the browser is concerned, that cookie is used to identify the user. So if I open an incognito window there, I'm going to go into the applications and cookies. We've got a new cookie there. I'm in because I've got a new session there because I'm in incognito mode. I'm going to go and take that cookie value. We'll go and copy and paste that. We'll go and paste over the top of that. And then if I manage to copy and paste that properly, when I refresh, sure enough, the application thinks I'm logged in as that user because it was used to identify me. What could we do about that? Well, that particular issue, of course, we want to make use of some additional protections and flags on the cookie. You will find most frameworks now will set these by default, but do check they're set. So once the HTTP only flag is set, then it stops JavaScript from going document.cookie. It doesn't have the ability to do that. Secure flag will ensure the cookie has to be sent over a secure connection. And then we have the newer one, which you may not have come across, same site. Now, same site has several different modes that it operates in. I've set it to use the strict mode. And what strict mode does is it says, I will only send cookies when the request originates from the same site that set the cookie. So if you don't have that, say I was on some forum somewhere and I had a link to hack the cat, on that first request, it will also send any cookies that it knows about for that application. But same site strict stops that and it says, oh no, you're actually coming from another site, so I'm not going to send those cookies. So that will help reduce or prevent some of these types of, not cross-site scripting, it's maybe a different set of issues, cross-site request forgery, but it can add additional security to your site. Do be careful with this because many sites would use this type of thing to load a profile up immediately, and of course you need to go and test this type of thing here. Very easy to enable though. I think a lot of sites now will use things like local and session storage for managing these type of tokens. I'm not sure whether it's necessarily a worse option, but it does mean that you don't benefit from things like HTTP only on the cookie, and there's nothing stopping someone reading that out the storage directly. Are we okay now? Have we fixed up our site? Well, no. The issue with we need to discuss around cookies is that by default they're passed. So when I go and access this web page, as far as the browser is concerned, any code running on this page is also running as admin here. It's using that cookie to identify this. So if I can trick this web page into running a request, when that request hits the endpoint, it's going to send the cookie, and the application is going to think I'm the currently logged in user or admin at hackthecat.com. So one thing we might want to do with this is we could use this to change the user's password. So we'll add in our XSS here. I'm just changing the username, password, and I'm going to change it to a known value, and I'm going to go and hit this endpoint. Now, this endpoint does require the user to be authenticated, but because I'm logged into this application as admin, then it's going to go and hopefully change my password. So here, I've just selected from what's currently in the user table. Obviously, in real life, you'd hopefully hash this or use an identity system, but for demo purposes, it's a lot easier to show you this in plain text. We'll save this and send it. And when that ran, I need to select from users. We can see we've then gone and changed that user's password there via XSS. So we're starting to get more and more serious with our XSS, from defacing the page to potentially getting access to the user's passwords. Because at this point, we've got an account set to a known value. Maybe an attacker then cycles through many different email addresses. Maybe they even know that you'll be registered on this site. If you took a common site like, say, Amazon, like how many of us in the room, are using Amazon? Probably, most of us. Cool. So when you have these type of functions, you need to authenticate that the user actually wants to do it. So something like a change password or maybe a make payment, you want an additional protection in place to stop that type of thing that I've just shown you. Because if the attacker had run that and we were asking the user for their password again, we wouldn't have been able to do that and change their password to a known value. Some of you might wonder whether things like cross-site request forgery tokens help with this type of thing. Well, it's not really the issue that this was designed to protect against. Yes, they make it very, very slightly more difficult. They're generally implemented as a hidden value on a page, which is sent with the request. An attacker has access to your page model. They can go and query any inputs and just send them along. So it's not really going to protect against that type of thing. What can we do to start making this our attackers' life harder? Csp policies. Now, Csp policies allow us fine-grained control of what should and shouldn't run on a web page. You can set them in meta tags or on HTTP headers. If I was to apply this particular policy, as you might expect, scripts from anywhere but the website specified, my website up there, will be blocked. That means if an attacker tries to reference a script on attacker.com.au, it's not going to work because we've told the browser, you should only be able to run some scripts here from this particular website. Now, you also get a number of other things out of the box. It will block inline scripts, event handlers, various execution methods that hackers like to use, and it makes their life a lot harder just with applying these simple protections. So in my example, we can go and apply these protections. Now, there is various frameworks and libraries which will set this. I'm just going to use this to set a header here in order to demonstrate what you'll see when you have these protections in place. So I'm going to set a content security policy header. I do need to stop the application in order for it to get it to pick up that change. I believe we've still got an XSS issue on this page with changing the password. I'm going to refresh that page and then bring up the browser console. And we can see here, we start getting some messages here about CSP policies and so on being violated. And that will provide some additional protections to us there. So that tends to kick around in the cache. So I'm just going to stop that and bring up the application, and I'm going to clear the cache because otherwise it's going to stop other things working that I want to show you. And we'll bring that up, and I'm going to go and clean out. We didn't have anything in there anyway. Cool. So CSP, when you first implement it, though, you'll very likely break your site. It's actually, there's quite a lot goes into it. In any non-trivial site, you're probably referencing many different libraries from different sources, and you'll find some of these other things like stopping things like eval by default. They will break existing applications. You'll find existing libraries, templating frameworks, doing all sorts of weird things you didn't know about, and they'll probably break your site. So what I recommend you doing, first of all, is you use the content security policy report only. That won't block these things, but it will output when they're blocked to the browser console, allowing you to understand when a policy is broken. If you do find items that you absolutely can't remove, you also have the ability to use nonce, I believe it's pronounced, and hash in order to say, this is the hash of this block of code here, in order for it to, and that's safe to run. So rather than allowing any old code, you need to have this specific hash in order to run. And that's for those sort of items that you can't remove easily. So will using a CSP prevent XSS? Well, it's very likely going to make an attacker's life much harder. However, there's different ways of circumventing some of these things. Some very creative minds behind some of these things. First of all, it's very easy to badly configure your Csp policies and get this wrong. You do have to test this. It's obviously not going to protect you if you screw up that configuration. Now, some frameworks have also had kind of some trapdoors via vulnerable methods. Angular, particular version of Angular had this. So they may also provide a way for an attacker to circumvent some of these things. I think one to watch out for, though, is callbacks, particularly in third-party libraries. Now, I want you to imagine a scenario where you've allowed, say, JavaScript from google.com. Maybe you're using their Maps API or something. Some of these libraries will allow you to specify a callback function in the reference that even though you've got a Csp policy saying only run scripts from google.com, if they provide a callback mechanism, that's allowed, and an attacker could then potentially use that callback equals to go and run their horrible script. So there may be ways around some of these things. Also be careful with leaving old versions of libraries. It's quite common in a large application. Maybe it's not maintained that well for several versions of libraries, frameworks, and so on do exist. These could also provide mechanisms for getting around some of this type of thing. Okay, well, we've changed the user's password, we've logged in as them, we've manipulated the web page, and we've popped up annoying JavaScript alert box. But let's talk about remote code execution, or RCE. Now, XSS can act as a bit of a stepping stone. It enables us to potentially run stuff in a higher privilege context. So if we can trick, say, an admin user into running some XSS on a page, then this might give us access to things we might not normally have. Now, it's quite common for admin and reference management interfaces to not be protected quite as well as that public stuff. Maybe we've got various methods for manipulating some of the data, uploading files, and so on. So there might be a lot more access via if we get an admin user to run something. I'm going to chain XSS with another issue, so I'm going to use XSS to trigger this particular issue in order to run code on this machine. Now, there's an issue in a library called Node Serialize. I'm not picking on this library, maybe a little bit. It is 8 years old. So this is a very old library. It's no longer maintained. It has known issues. If you try and install this to your project, NPM will warn you this has a critical vulnerability. Alert, alert, do not use this in your application. So you'd have to be a little bit silly to make use of this. So Node Serialize, as you might imagine, it serializes JSON data. There is better ways to do this now. I don't recommend you use this. But interestingly, it also provides the ability to serialize functions on an object. And even better than that, if these properties begin with the string ndfunc, it runs them. And that should be running alarm bells for people at this point. We have a serialization library that if you give it a blob of JSON that has this string ndfunc in it, that library will take what's in that property and run it. I'm not sure why you would ever want to do that. If you want to go and have a look at the code yourself, that's where it is. As I said, it's no longer used, but I took this screenshot on Sunday. I don't know if you can see from there the weekly downloads there. There was over 1,300 people that downloaded this last week, and I'm pretty sure they're not downloading my Learn Security application. And this is consistent across many weeks. Like, how many applications out there are using this library at the moment? It's 8 years old. NPM warns you should not be using this particular library, and it provides the ability by providing malformed JSON to run code, as I will show you. I find that a little bit scary. What are we going to pass it? Well, when you're playing with this type of thing, it's a good idea to do more simple things first, because if we immediately jump to creating a connection from the remote machine back to us, then there may be other things in place, such as firewalls, other protections. We don't know whether that necessarily works. So what I'm going to start off by doing is just getting this to go and create a file. I'm going to use the touch command there in order to create a file called hello.ndc.txt. So we'll come out of that, and I'm going to go into my command prompt here. Let's go and remove that there, and just to show you that doesn't exist, we're back there. Now, what I'm going to do here is I have a block of JavaScript. It creates a bit of JSON with that property of ndfunc. I'll show you that again in a minute. We know this has got an XSS issue there. In our form data, we have a property called ICE. We've got this string, and then it's going to run whatever we pass in the command there. In this example, hello ndc.txt. We'll go and submit that. And then if I've done that right, when we go and look at that out again, ooh, we didn't get it there. Oh, did I miss a tag?
The beginning tag of the script.
Ah, thank you. I'm glad I got you guys checking.
We're awake, Alex.
We are. Which is good, because I was curious as to why that didn't work. So hopefully we've done that, and then sure enough, we've got our file created there. We've supplied it some bad JSON, and we've now have the ability to create a file on the machine here. That's a little bit scary. Now, if it was certain types of applications, such as a PHP application, we could create what's called a web shell, or we could create a single PHP file which will execute operating system commands and connect back to our machine. We're going to do that now. So we're going to go back to our application here, and let's stop Netcat, and let's go and just get rid of all the comments there. So we've reset. And we're going to do something called a reverse shell. What's a reverse shell? Well, we're all familiar with a shell, command line interface. That bit over on the left there, that server there, that's our victim machine, if you will. And what we're going to do is we're going to tell that victim machine to connect back to a port on our machine. Now, the reason we do it that way is generally there's less protections in place that way. Like, you'd have to be a bit of an idiot to leave a web server with all the different ports exposed directly to the internet. It does happen, but generally there's less restrictions from the web server back to us. So we're going to initiate we're going to tell it to connect back to our machine and bind that traffic to a shell on that machine there. And I'm going to connect to Netcat again. We used that earlier when we stole the cookies. And I'm going to take my code. And rather than just touching a file, we'll take this. And let's just refresh that. And we'll paste that in. What does our reverse shell look like? Well, look, it does involve a bit of node code, and I'll be honest, it took me a couple of hours to get the comments and, not the comments, the quotation marks correctly, and so that it didn't screw up the encoding when it was received. But you can see here we're using the net library and child process, and we spawn processes, sockets, and so on. I'll put it up later, you can go through it. And then we're going to connect back to our own machine on port 9000. So we'll set up our Netcat listener there, and we'll go and submit that and run it. And then if everything works well, you can see we've got connection received there. In this instance, I'm running everything on my own machine. Yes, I guess I've pawned my own machine here, but the principles are the same as if it was a remote machine. So this isn't just a connection back. This is interactive here. So I could enter any command that I'd normally be able to enter. We could go and, I don't know, wget, put all sorts of malicious stuff on there, and it's from here an attacker might look at elevating their permissions. So hopefully you're not running your web application as root or a privileged account, because then you're going to have full access to do whatever the hell you like on this machine here. An attacker would probably then look for various ways to elevate their permissions. There's been a lot of issues, particularly sort of Linux world, various things you can run, which will take a low privileged account and turn it into a higher privileged account. So then it's kind of game over for that web server. Or, as an attacker, we could be connecting to the database potentially, reading passwords, stealing databases, whatever it is that they feel like doing. So that wouldn't have been possible, though, without XSS. Yes, we did use it with another vulnerability there, but that endpoint might have only been able to be used by an admin or a privileged user. So hopefully that's demonstrated that XSS can be a really serious issue. Detecting XSS is really hard. Like, you might think, oh, I'll just look for some chevrons or script blocks, something like that, in order to go and prevent this. Well, it's really hard because there's so many different contexts and different ways that you can run XSS. It almost becomes a bit of a... looking at some of these things is kind of a tour of the weird edges of JavaScript and web APIs, and there's some very creative ways of running some of these things. Probably some of the better known stuff, we can use things like onload attributes, or we can use onError. We can deliberately trigger an error in order to get this stuff to fire. We can use the JavaScript sort of pseudo protocol to get stuff to run. We could trick a user into running something. A lot of the other things tend to be blocked. People know about them. But say something like access key, designed for keyboard accessibility and so on, if we can trick a user into running that, we can get them to run this XSS. Filtering out this stuff is really, really hard. So this listed up here is all the different ways that you could do that sort of left chevron there. I haven't counted those, but there's a heap of different ways. So if you're just looking for the character, depending on how the content is rendered, the framework, the web server, some of these things could end up getting rendered. If you're looking for particular strings, there's various different ways you could evade them. If you're not careful with the casing to do case-insensitive comparison, people could get around some of this stuff that way. They could add extra spaces in, brackets, a null character. Web servers, particularly Linux ones, tend not to like this. Don't close tags. Sometimes there'll be code in place reading through tags. JavaScript from Cara code and put a load of stuff together in order to hit some of these issues. And then, of course, there's 100 different encoding mechanisms, decimal, hex, octal, UTF-7. There's probably 1,000 different ways of doing this. And we talked about malform tags on browsers earlier. Now, one reason I think people don't or aren't so familiar with some of these issues is that modern frameworks do a pretty good job of protecting you from some of these issues. Most of them have some pretty sensible defaults, and you kind of have to go off the beaten track in order to shoot yourself in the foot. People do, though, and we'll talk about that in a minute. React has the just beautifully named method dangerously set inner HTML. Now, React warns you you're about to do something dumb there. If you don't get that message from that and go, why is this dangerous, then I love how that's named, though. It is well named. And look, there is reasonable scenarios where you may need to use this type of thing, where you've in control of the input and where you've already sanitized it. If you do find yourself looking at these things, there is probably better ways to do it. Let's talk about this with React. I'm going to close that one down. I have a very simple React application. It uses some different ways. So it's npm. I'll get that to start. Very simple React application. I have a text box here. When I change this text, you can see those other items update as we'd expect. Now, using default binding, this will be the output you see. If we use dangerously set inner HTML, then this is the output. And I've also got this stuff bound to a hyperlink there. So you can see in the highref value, I'm just binding that there. I'm not a React person, but I do want to show you some examples here. So our first example, if we go and put in an iframe there, and in the source we set that to JavaScript alert, as you can see, we've got this box popping up here. Now the reason for that is because I've used that dangerously set inner HTML there. I've told React, I know what I'm doing, don't encode this, run it as I give you, and sure enough, that XSS issue ran there. I needed to use an iframe rather than a script block because the page is already loaded, and if I just add that, then it's not going to trigger that there. Now, in an interesting one with React, however, is this JavaScript Protocol one. So if we go and do JavaScript alerts there, when that's bound to the hyperlink one, React doesn't actually filter that one out. And I think that's not what a few people would expect. And granted, it's not as serious as running it on the page, but I suspect there's probably a few applications binding stuff directly to that. So do be careful with that one. On the whole, though, I think React does a really good job of keeping you safe. You kind of have to go off track in order to get yourself into trouble. If you find yourself doing things like .inner HTML, refs, and React offers a few different trapdoors, be very, very careful because React is no longer giving you some of the protections it has by default. So if you do find you're using those type of methods, there's probably a better way to do it. So, in summary, XSS, hopefully I've persuaded you, it can be really serious. It's not just popping up annoying alert boxes. It could potentially lead to full compromise of an application or machine. It's highly prevalent. This is still very much out there. Use defense in depth. I make sure you encode your output, consider sanitizing input from the user, use those secure cookie options and Csp policies. Most frameworks now have sensible defaults. I had to deliberately disable some of the options and some of the libraries and frameworks I was using there to show some of those issues. So for example, the session management system, by default, HTTP only is set to true. ASP.NET Core will do this type of thing as well. There's a lot of sensible defaults out there, and you have to go and circumvent them to get impacted by them. When you're putting together your applications, design them with security in mind from the start. It's not just the job of your AppSec team, if you're lucky enough to even have one in your organization. Work with the other developers, get everyone together, and look at all the potential ways that people might want to exploit these issues. Get business people, get their input as well. It doesn't have to be just technical people. Someone might say, well, hey, what if you could do this? And you may have found another issue in your application you hadn't considered. In order to find some of these things, I think it's best to use a combination of automated code quality tooling, things like Mend, Sneak. These will do things like flag vulnerable libraries, sometimes vulnerable code constructs. You're not going to catch everything, however. And there's various scanners out there where you can point it at a URL and it will fire various payloads in an attempt to discover issues. These worked kind of well in the past, but if you think of the modern day SPA application, it's really hard to kind of spider this application, find all the endpoints. They don't work so well with these type of things. So by all means, make use of automated tooling, but it is going to require some element of manual review. Do check you've got permission to do it. Please don't go out there and do this on the stuff you don't have permission to. But put all these things together and hopefully you'll have a pretty secure application. If you do want to learn more about this, I suggest you head over to something called the Portswigger Labs. Portswigger produce a tool called Burp. It's a proxy designed with security in mind. You don't have to use it for security, but it has a lot of features to do with security. They offer a free version. It's a really, really good tool. It looks a bit clunky at first. I think it's written in Java and it looks a bit ugly, but it's a really good application, and there is a free version available. It enables you to manipulate requests very easy, encode, repeat stuff. They have a really great set of labs that you can run through, and they're all free. And there's probably about 25 different topics they cover, from XSS, SQL injection, template injection. There's 100 different things, and there's a few things that you're looking at and you're like, I've never heard of that. What even is that? Really great learning resource there. There's also a book. It's written a while ago now, 2011, the Web Application Hacker's Handbook. This is a bit of an eye-opener. This book is still really, really relevant, and you'll go, oh my God, I never thought of that. It's quite a thick book, but there's like 1,000 different sort of attacks, and it tells you, if this is blocked, do this. And it's a really extensive, deep guide of some of these issues. That's eXential XSS. Hopefully, that's been a great way to go and show the seriousness of some of these issues. Please go and learn about security, learn what the attackers are going to do to your applications. By learning this, we can better defend our applications. Thank you very much. Has anyone got any questions? Or am I keeping folks from lunch?
You mentioned can exploit XSS using CSS as well.
Yes, yes.
What do you do with that?
Yeah, there's if you go to, I think it's Scott Helm, he has an entire blog article on this where someone creates a keylogger using CSS. And it's pretty creative, but basically it uses, there's some properties of CSS before and after, and then you can use it to request different images. And then you can work out from those requests, because the rule triggers, someone types an A, and then it gets a different thing. And I'm like, wow, who even comes up with that stuff? But check out Scott Helm's blog. He's got a great blog article on that. Well, if you do have another question, please come see me afterwards. Otherwise, enjoy the rest of the conference. Thank you.